Today we are going to start our fourth chapter that is related to structure of atom. As we know, structure of molecules. As we know, the different atoms combine together and make a molecule, and their arrangement and their structure is very different. There's the difference between the structure of the different molecules is due to the bondings, that which type of bonding is present in them. But the most important thing, that why atoms combine together and make a molecule, why they need to combine together, which thing force them to combine chemically and make a bond. So this is the real question. Why do atoms form chemical bonds? Basically, atoms form chemical bond to attain the electronic configuration of noble gases. Those are the noble gases: helium, neon, argon, krypton, xenon, radon. These are the noble gases. These noble gases are the basically 18th group of the periodic table. 18th group of the periodic table. In the very right side of the periodic table. These noble gases are also called as inert gases, and the group is also called as zero group. These noble gases having 8 electrons in their valence shell from neon to radon, and 2 electrons in the atom of the helium. So atoms want to attain the electronic configuration of these noble gases, means they want to have 2 electrons in their outermost shell or 8 electrons in their outermost shell. If the atom is of hydrogen or helium, as we know, these both having just one shell, only just K shell, because hydrogen having atomic number 1, helium having atomic number 2, not more than this. So that's why they just having a one shell. So they both follow the duplet rule. They will be stable when they have 2 electrons in their outermost shell. So this is called as duplet rule. Duplet rule. When the atom having 8 electrons in their outermost shell, like neon, argon, krypton, xenon and radon, they are stable, they are unreactive. This rule is called as octet rule. To attain electronic configuration like noble gases neon, argon, krypton, xenon and radon. So atoms want to stable. For that stability, they combine together. They share electrons, they donate electrons, they accept electrons. In this way, they combine together and make a chemical bond. Safa, don't write on my screen. They combine together and make a electronic configuration as noble gases. When atom take electron and when atom lose electron and when atom share electron. If the electron having less than 3 electrons, in their valence shell, then what will happen? If the atom having less than 3 electrons in their valence shell, so they will lose their electron. If the atom having more than 4 electrons, means 5 to onward, 5 to 7 for example, electrons in their outermost shell, more than 4 electrons means 5 to 7 electrons in their outermost shell, they will gain electrons. So remember this, if the atom having less than 3 electrons, they will lose electrons. If the atom having 4 to 7 electrons in their outermost shell, they will gain electron. So what about the atoms having 4 electrons or a little bit near to this? They will share electrons. They will share electrons and make a chemical bond. Why they are sharing, donating or losing electrons? To attain the electronic configuration of noble gases, which means they want to be follow octet rule. They want 8 electrons in their outermost shell. Remember this, duplet rule is just for hydrogen and helium because these two atoms having just one shell. That's why this rule is followed by helium and neon. Next, what is chemical bond? Chemical bond is defined as the force of attraction between atoms that holds them together. This is basically an invisible force. That force attracts the atom, keep them together. That force is basically called as a chemical bond. There is nothing, any rod or any thread to hold the atom. There is just attractive forces as magnet attracts the metal itself, magnetic force. In the same way, there is a force between the atoms to keep the atoms together. That attractive force is basically called as a chemical bond. There are different types of chemical bonds. Ionic bond, covalent bond, dative covalent or coordinate covalent bond, metallic bond. Ionic bond is formed by the gain or lose of electron. Covalent bond is formed by the sharing of electron. Dative covalent or coordinate covalent bond is formed by the donation of one pair of electron from one bonded atom. In this bonding, only one atom donate a complete pair of electron, not a single electron, complete pair of electron. And in metallic bonding, metals combine together and make a bonding when there are freely moving ions and electron in a medium. So there are 4 types of chemical bonding. In a detail, we are going to discuss about the ionic bonding. What is ionic bonding? Let's see. Ionic bonding is basically the complete transfer of electron from one atom to another atom. For example, there are 2 atoms, atom A and an atom B. In ionic bond, one atom completely transfer its electron and another atom takes that electron. This type of bonding is called as ionic bonding. If one atom donate its one electron, so it will contain positive charge. If one atom take electron, it will contain negative charge by the gain of electron. So these 2 atoms becomes ions. That's why it is called as ionic bonding. First ions form. Due to that ion, the atoms having electrostatic force of attraction for each other. Due to that electrostatic force of attraction for each other, these ions combine together and make a compound. See this example. Here you can see the ions in ionic bonding, the ions combine together. For example, we are taking example of NaCl, sodium chloride. This is the electronic configuration at ground state, in which there is no transfer of electron or no gain of electron. In a sodium atom, first shell having 2 electrons and the second shell having 8 electrons and the third shell having 1 electron. These are the electronic configuration in subshells. First shell 1s2 is representing first shell. First shell having 2 electron. 2s2, 2p6 is representing second shell, L shell. This is K shell. And 3s2 is representing third shell, M shell, and the subshell is S. S subshell having 1 electron. So you can see in a third shell there is just one electron. For to complete the octet rule, it needs 7 electrons. In a chlorine, first shell contains 2 electrons, second shell contains 8 electrons, and the third shell contains 7 electrons. There is a lack of 1 electrons to complete octet. It needs 1 electron to complete its outermost shell, to complete its valence shell. To attain 8 electrons in their outermost shell, chlorine needs 1 electron and sodium needs 7 electrons. Sodium is electropositive. In a previous chapter, we have discussed about the ionization energy, electron affinity, and their nature in a period and groups. So, due to its electron positive nature, due to the ionization energy, sodium atoms release 1 electron in their outermost shell because of electropositive nature. So, when sodium will lose its 1 electron from its outermost shell, for example, sodium lose this outermost shell, this complete shell will be removed like this. Now, sodium has lose the 1 electron, which shows its outermost shell is completely disappear, because if there is no electron, then there is no shell. Because shell is basically an energy level. If there is no electron, then there is no energy. So, atom will lose 1 electron, sodium atom will lose 1 electron. Now you can see this second shell is the outermost shell for this sodium atom, sodium ion, not atom. Now it's an ion because it has loses 1 electron. It's a positive ion. So now this sodium ion having second shell, its valence shell. You can see now its valence shell having 8 electrons. Now this is following the octet rule because its valence shell having 8 electrons. First shell having 2 electrons and the second shell having 8 electrons. In a chlorine atom will accept that electron which is lost by sodium atom. When chlorine will take that electron, its electronic configuration will change. You can see here. First shell having 2 electrons, second shell having 8 electrons, and the third shell now by taking 1 electron having 8 electrons. Previously, third shell having 7 electrons. 2 shell in a S subshell and 5 electrons in a P subshell. Total 7 electrons in third shell. By taking that 1 electrons, now chlorine having 8 electrons in its outermost shell. So chlorine is also following octet rule, noble gases configuration. Noble gases having 8 electrons in their outermost shell except helium. Helium is following duplet rule. So the electron atom, those having less shells, not 2 shells, not properly 2 shells, they will not follow the octet rule. They will follow duplet rule. So octet rule is now followed by both the atoms, sodium plus chlorine. Now both having 8 electrons in their outermost shell. Here you can see the proper structure to better understand this. Sodium having 1 electron in its outermost shell, chlorine having 7 electrons in its outermost shell and lacking 1 electron. There is a space empty for 1 electron. Sodium will lose its 1 electron and becomes positive ion. Chlorine take that electron which is lost by sodium and becomes negative ion. Now this is sodium ion and this is chloride ion. These positive and the negative ion in a medium attracts each other by electrostatic force of attraction. By electrostatic force of attraction and become a compound. Ionic compound due to ionic bonding. Ions form first, then these ions combine together and make a bond. So in exam, you can draw the structure of this ionic compound of sodium by showing the shells by doing the electronic configuration, or by showing the loss of electron or gain of electron in form of equation. Let's see. How you can show in the form of equation. Sodium, you just show one electron of outermost shell, one electron of valence shell. No need to show all the electrons. Just show valence shell electron. This sodium will lose the electron. This is a reactant. Loosed electron will be represented in a product. On the left side of this sign, all are reactants. On the right side of this arrow, all are products. Clear? So sodium will lose one electron. That loosed electron will be represented in a product like this. One electron is lost by sodium. Now sodium becomes positive ion. This is another way to represent the ionic compound. This one electron will be taken by chlorine. Chlorine having 7 electrons in its outermost shell. Lack of one electron. So this one electron that is lost by the sodium will be taken by chlorine. So now this is a reactant. Chlorine taken the one electron. This one electron is going to be added in this chlorine. So now these two are now reactants. Equation's product will be chlorine ion. This is a product. Now you can see sodium ion is formed by the loss of electron. Chloride ion is formed by the gain of electron. In the last net equation, you have to write Na plus Cl negative, and the product is NaCl. This is your product by the attraction between the ions. So this is another way to represent your ionic compound, or you can represent the ionic compound by drawing the complete structure, electronic structure like this in this way. You can also represent it in this way. You have to do this electronic configuration while you are writing about the ionic compound. So if the question about ionic compound is in a long question, you have to keep in mind that you have to show the electronic configuration in shells and subshells, draw electronic configuration structures, or show the equations also. Next, here you can see another example of ionic compound. Before explaining this ionic compound and the example of ionic compound, I want to give you the idea about dot and cross structure. Dot and cross structure. Nothing to worry about dot and cross structure. By the dots or by the cross, electrons are represented. If you having a compound like this, NaCl, so if the examiner say to you that draw the ionic structure of NaCl by dot and cross, or if they say draw the Lewis structure diagram. Dot and cross structure, Lewis structure is the same thing. Lewis structure is basically the dot and cross structure. In the dot and cross structure, you have to represent the electrons of one atom as a dot and the electrons of another atom as a cross. So if I am showing the electrons of sodium as a dot, so for chlorine I am going to represent the electrons as a cross. Chlorine having 7 electrons in its outermost shell, so I am representing it as a cross. So this is basically the dot and cross structure. So don't be worried about this, that what is a dot and cross structure. Basically dot and cross structure is you are representing electrons of one atom as a dot and electrons of another atom as a cross. In this equation you can see both the electrons are representing as a dot. So this is also not a wrong thing. You can also represent it like this. But if the examiner say draw Lewis structure, draw dot and cross structure, then you keep in your mind you have to make electrons of one atom as a dots and the electrons of another atom as a cross, not the dot. I'm going to give you the example of another ionic compound, which is magnesium chloride. Magnesium is from group 2, as we know of the periodic table. The elements of group 1 having 1 electron in their outermost shell, and the elements of a group 2 having 2 electrons in their outermost shell. So sodium from the group 1 and magnesium from the group 2. That's why sodium having 1 electron in its cell, in outermost shell, that's why it is losing just 1 electron and becomes positive 1. Magnesium having 2 electrons in its outermost shell. So if magnesium wants to complete its octet, wants to attain the electronic configuration of noble gases, so magnesium should have to release 2 electrons, should have to lose 2 electrons and become plus 2, 2 plus. The second is chlorine. As we know, the one chlorine having 7 electrons in its outermost shell, and a one chlorine atom needs just 1 electron. So here are 2 chlorine atoms. So each chlorine atom will take each single electron of magnesium. You can see here the first shell of magnesium having 2 electrons, and the second shell of magnesium having 8 electrons, and the third shell of magnesium having 2 electrons. So each electron of magnesium is transferred to each atom of chlorine. The one electron is transferred to one chlorine atom, and the another electron is transferred to another chlorine atom. In this way, this chlorine atom become minus. 1 minus, and this will be 1 minus, and magnesium will be 2 plus. So minus 1 will be minus 2. So minus 2 plus 2 cancel out each other, and it is neutral. That's why magnesium chloride is a neutral molecule.